Imagine a future where humans walk on Mars not just as explorers but as settlers. Picture a bustling Martian colony with people living their daily lives millions of miles away from Earth. Picture them living and working on the red planet, engaging in activities that sustain their new home. They would need to build, maintain, and innovate to survive in such a harsh environment. A fundamental question arises: what will they eat? The diet of these Martian settlers is crucial for their survival and well-being. Bringing food from Earth would be incredibly expensive and unsustainable. The logistics of transporting enough food for a growing colony are daunting. That's where the fascinating concept of space farming comes in. By growing their own food, settlers can become self-sufficient and reduce their reliance on Earth. Growing food on Mars is no longer science fiction, it's a necessity for the future of space exploration. Scientists are developing innovative methods to cultivate crops in Martian soil. We must learn to cultivate crops in this alien environment to support human life. This involves understanding the unique challenges posed by Martian soil and atmosphere. This undertaking isn't just about filling Martian stomachs, it's about pushing the boundaries of human ingenuity. Advanced farming technologies are being tested to ensure success. It's about proving that we can thrive beyond our home planet. A successful harvest on Mars would be a monumental achievement for humanity. The quest to grow food on Mars is a testament to our relentless spirit of exploration and our determination to turn science fiction into scientific fact. It symbolizes our drive to overcome obstacles and create a sustainable future on another world.
We've already started experimenting with space farming. On the International Space Station, astronauts have successfully grown various vegetables. These experiments are crucial. They give us valuable data on how plants grow in microgravity and with limited resources. One of the most exciting developments is the veggie system. This compact unit uses LED lights to help plants grow in space. Astronauts have enjoyed fresh lettuce and other vegetables grown in the veggie system. Imagine the psychological boost of enjoying a fresh salad after months of prepackaged meals. These initial successes are just the tip of the iceberg. They pave the way for more ambitious projects aimed at creating sustainable food systems for future Martian settlements. Our journey from earthbound agriculture to cultivating crops on an alien planet is well underway. Growing plants on Mars isn't as simple as replicating Earth's conditions. The red planet presents a unique set of challenges. The Martian atmosphere is thin, offering little protection from the sun's radiation. This radiation can damage plant cells and hinder growth. The Martian soil, known as regolith, lacks the essential nutrients found in Earth's soil. It also contains salts that are harmful to plants. Another challenge is the Martian climate. Temperatures fluctuate wildly, and the planet experiences frequent dust storms that can block sunlight for months. These challenges seem daunting, but they also present incredible opportunities for innovation. Overcoming these obstacles will require us to rethink traditional farming methods and develop cutting-edge solutions. The pursuit of Martian agriculture is not just about feeding future colonists, it's about driving technological advancements that could revolutionize agriculture here on Earth. Scientists are developing innovative technologies to address the challenges of Martian farming. Hydroponics, a method of growing plants without soil, offers a promising solution. In hydroponic systems, plants receive nutrients directly from water, bypassing the need for fertile soil. Solar panels will play a vital role in powering Martian greenhouses. Mars receives ample sunlight, making solar energy a reliable and sustainable power source. Artificial lighting will also be crucial, especially during dust storms or the Martian winter. LED lights, which emit wavelengths ideal for plant growth, can supplement natural sunlight. These technologies, combined with advancements in robotics and automation, can help create controlled environments where plants can thrive. The harsh Martian environment demands ingenuity and innovation. It pushes us to find new ways to cultivate life and make the seemingly impossible possible, testament to human ingenuity and perseverance. Section 6. Water. The essential ingredient. Water is essential for all life, including plants. While Mars has polar ice caps and subsurface ice deposits, extracting and purifying this water for agricultural use presents a significant challenge. One promising solution is to use robots or rovers equipped with drills to extract ice from the Martian surface or subsurface. This extracted ice can then be purified and delivered to greenhouses. Another approach involves developing technologies to capture and condense atmospheric moisture. Although the Martian atmosphere is thin, it does contain some water vapor, which could be collected and used for irrigation. Securing a reliable water supply is crucial for the success of any Martian settlement. The ability to utilize Martian resources like water ice will determine our self-sufficiency on the red planet.
Section 7. Scaling up for sustainability. The success of Martian colonies hinges on our ability to scale up these technologies to create self-sustaining agricultural ecosystems. This means going beyond small-scale experiments and developing systems that can provide food for entire communities. Imagine interconnected domes, each housing a specialized agricultural zone. One dome might focus on growing staple crops like wheat or potatoes, while another could be dedicated to fruits and vegetables. These domes could be linked by automated systems that transport nutrients, water, and harvested crops. Another key aspect of sustainability is waste recycling. On Mars, every resource will be precious. Systems that can compost plant waste and recycle water will be crucial for long-term sustainability. The goal is to create a closed-loop system where resources are used efficiently and waste is minimized.
Section 8. A vision of Martian farms. Imagine standing inside a Martian greenhouse bathed in the warm glow of LED lights. The atmosphere is surreal,
Almost otherworldly, yet filled with a sense of hope and possibility. Rows of vibrant green plants stretch as far as the eye can see, a stark contrast to the red landscape outside. These plants are not just surviving, but thriving, thanks to advanced technology and human ingenuity. The air is filled with the earthy scent of fresh herbs and vegetables. It's a reminder of Earth, a connection to our home planet, even millions of miles away. This is not a futuristic dream, but a potential reality. With each passing day, we move closer to making this vision a tangible part of our future. Martian farms, once a staple of science fiction, are within our reach. What was once imagined in books and movies is now being designed and tested in labs and simulations. The challenges are significant, but so is the human spirit of innovation and exploration. Every obstacle is met with determination and creativity. The quest to grow food on Mars is about more than just survival. It's about creating a sustainable way of life, ensuring that future generations can thrive on the red planet. It's about pushing the boundaries of human ingenuity and demonstrating our ability to thrive in the most challenging of environments. Each successful harvest is a testament to our resilience and adaptability. It's about carrying the torch of exploration forward and establishing a permanent human presence beyond our home planet. This vision of Martian farms is a crucial step in our journey to become a multi-planetary species.
Section 9. A giant leap for food. The journey to establish self-sustaining colonies on Mars is a monumental undertaking, one that challenges our current technological and scientific capabilities. It will require global collaboration, scientific breakthroughs, and unwavering determination from the brightest minds across the world. However, the potential rewards are immense, offering new frontiers for human ingenuity and survival. Successfully growing food on Mars will be a giant leap for humankind, not just for space exploration but for agriculture and sustainability here on Earth. Imagine the possibilities of cultivating crops in an environment so different from our own. The technologies we develop for Martian farms could help us address food security issues and promote sustainable practices here on our own planet. These innovations could revolutionize how we grow food, making it more efficient and resilient. The dream of space farming is not just about feeding future Martians, it's about ensuring a food-secure future for all of humanity. It's about creating systems that can withstand the harshest conditions, both on Mars and Earth. It's about pushing the boundaries of what's possible and inspiring generations to come. The sight of a rocket launching into space can ignite the imagination of young minds, encouraging them to dream big and aim high. As we venture further into the cosmos, we carry with us the hope of a brighter future, one where humanity thrives not just on Earth, but among the stars. This journey is a testament to our enduring spirit and our quest for knowledge and survival. Developing innovative technologies to grow food in microgravity, experimenting with different plant species, travelers, but for all of humanity. To secure a future where everyone has access to nutritious food, we must look beyond the confines of our planet. Space exploration has always been driven by a spirit of discovery, but it is increasingly becoming a necessity for the survival of our species. Space farms offer a potential solution to the limitations of Earth-based agriculture. By growing food in controlled environments beyond our planet, we can supplement our food supply, reduce our impact on Earth's ecosystems, and pave the way for long-duration space missions and the establishment of self-sustaining colonies on other planets. Traditional agriculture, while essential for sustaining human civilization, faces a growing number of challenges. Climate change is causing more extreme weather events such as droughts and floods, which can devastate crops and disrupt food production. Soil degradation, caused by factors like deforestation and intensive farming practices, is reducing the amount of fertile land available for agriculture. Water scarcity is also a growing concern, as agriculture accounts for a significant portion of global freshwater use. Space farming offers a potential solution to these challenges by allowing us to grow food in controlled environments that are not subject to the same limitations as Earth. In space, we can regulate temperature, humidity, and light exposure to create optimal growing conditions for a wide variety of crops. Furthermore, space farms could help to reduce our reliance on pesticides and herbicides, as the closed-loop systems used in space agriculture minimize the risk of pests and diseases. By growing food in space, we can also reduce the environmental impact of agriculture on Earth, freeing up land and resources for other uses.
Section 5. Early steps on the final frontier. The idea of growing food in space is not new. Scientists have been conducting experiments on the International Space Station for years, exploring the possibilities of space agriculture. Astronauts have successfully grown a variety of crops in microgravity, including lettuce, radishes, and even flowers. These experiments have provided valuable insights into the challenges and opportunities of growing plants in space, paving the way for more ambitious projects in the future. The knowledge gained from these early experiments will be crucial as we work towards establishing larger-scale space farms that can provide a sustainable source of food for future generations.
Section 6. The science of growing beyond Earth. Growing plants in space requires overcoming unique challenges not encountered on Earth. The unique environment of space, with its microgravity, radiation, and limited resources, presents a new frontier for agricultural science. The absence of gravity, for example, affects plant growth in various ways, from water distribution to root development. In zero gravity, water doesn't flow downwards but forms floating droplets, making traditional irrigation methods ineffective. To address these challenges, scientists are exploring innovative techniques such as hydroponics and aeroponics. These methods are not only efficient, but also adaptable to the unique conditions of space. Hydroponics involves growing plants in nutrient-rich water solutions, allowing for precise control over the nutrients the plants receive. This method is particularly useful in space where soil is not available, while aeroponics involves suspending plant roots in the air and spraying them with a fine mist of nutrients. This technique ensures that the roots receive adequate oxygen and nutrients, promoting healthy growth. These methods eliminate the need for soil, conserve water, and allow for greater control over plant growth. In space, where water is a precious resource, these soil-free systems are particularly advantageous. Artificial lighting systems, such as LEDs, are used to provide the necessary light energy for photosynthesis. These lights can be fine-tuned to emit specific wavelengths that are most beneficial for plant growth, simulating the sunlight plants would receive on Earth. Monitoring and data analysis are crucial components of space farming. Astronauts and scientists continuously monitor plant health, growth rates, and nutrient levels to ensure optimal conditions. The ultimate goal is to create a sustainable and self-sufficient system that can support long-term space missions and even future colonies on other planets. By growing a diverse range of plant species, we can ensure a balanced diet for astronauts and reduce the need for resupply missions from Earth. The science of growing beyond Earth is not just about survival, it's about thriving in new environments. As we continue to explore the cosmos, these advancements in space agriculture will play a crucial role in our journey. Section 7. Shielding crops from cosmic dangers. Space is a harsh environment, and protecting crops from cosmic radiation and extreme temperatures is crucial for the success of space farming. Shielding materials such as water or regolith, the loose, unconsolidated material found on the surface of planets and moons, can be used to absorb or deflect harmful radiation. Temperature control is another important consideration. Greenhouses can be designed with reflective surfaces to minimize heat absorption, while cooling systems can be used to maintain optimal temperatures for plant growth. By carefully controlling the growing environment, we can mitigate the risks posed by the harsh conditions of space. Need for materials to be transported from Earth. Section 9. Overcoming the hurdles of space. Despite the potential benefits of space farming, there are significant challenges that must be overcome. The cost of launching and maintaining space-based infrastructure is currently very high, although advancements in reusable rockets and in-space manufacturing are expected to drive down costs in the coming years. The risks associated with space exploration, such as equipment failures and launch accidents, also pose challenges for space farming. However, as technology continues to advance and we gain more experience operating in space, these risks are expected to decrease. Section 10. A vision of abundance by 2045. By 2045, space farming has the potential to revolutionize the way we produce food and ensure food security for a growing global population. With the increasing challenges of climate change, soil degradation, and water scarcity on Earth, space farming offers a promising alternative. Imagine a future where space farms provide fresh produce to communities in food deserts, transforming urban landscapes and making nutritious food accessible to everyone. These space farms could operate year-round, unaffected by earthly weather conditions, ensuring a consistent supply of fresh produce. They could supplement the diets of astronauts on long-duration missions, providing them with the necessary nutrients to maintain their health and well-being in the harsh environment of space, and even sustain the first human settlements on other planets, making it possible for humans to thrive beyond Earth. These space farms could be the backbone of extraterrestrial colonies, ensuring that settlers have access to fresh, healthy food. This vision of abundance is within our reach. With advancements in technology and a commitment to innovation, we can turn this vision into reality. By embracing the spirit of exploration and innovation that has always defined humanity, we can push the boundaries of what is possible. Scientists and engineers are already working tirelessly to develop the technologies needed for successful space farming. We can overcome the challenges of space farming, such as microgravity, radiation, and limited resources, through innovative solutions and collaborative efforts, and unlock a future where food is no longer a limiting factor in our pursuit of the stars. A future where every person, regardless of their location, has access to fresh, nutritious food, and where humanity can thrive both on Earth and beyond. Food, recycle resources, and minimize waste. We need to grow food on Mars, for the pioneers who dare to call it home, and for the future of humanity. Growing food on Mars isn't as simple as scattering seeds and waiting for a Martian harvest. The red planet throws some serious curveballs our way. First off, Martian soil isn't exactly what we call arable. It lacks the essential nutrients and microorganisms that Earth plants need. Then there's the water problem. While there's evidence of water ice on Mars, accessing it and making it suitable for agriculture is a huge hurdle. And let's not forget the elephant in the Martian room, the atmosphere. It's thin, mostly carbon dioxide, and offers little protection from the sun's harmful radiation. Imagine trying to grow a tomato in a windstorm on top of Mount Everest. That's the kind of challenge we're talking about.
Luckily, we humans are a resourceful bunch, especially when it comes to food. Our ability to innovate and adapt has always been one of our greatest strengths. We're already developing ingenious solutions to outsmart Mars and its less than ideal farming conditions. The challenges are immense, but so is our determination. Take Martian soil, for example. Scientists are creating special soil substitutes packed with nutrients and designed to mimic Earth-like conditions. These substitutes are tailored to support plant growth in an environment that is otherwise hostile to life. Imagine Martian farms blooming with life, fed by a soil engineered right here on Earth. These farms could one day provide fresh produce for astronauts and settlers, making long-term habitation on Mars a reality. Water scarcity? Not a problem. We're developing technologies to extract water from the Martian atmosphere and even from underground ice deposits. These advancements are crucial, as water is essential for both drinking and farming. It's like pulling drinking water out of thin air, quite literally. This technology could revolutionize how we access water in space, ensuring a steady supply for all our needs. And for that pesky atmosphere issue, we're turning to hydroponics and aeroponics. These innovative farming techniques allow us to grow plants without soil, using nutrient-rich water solutions and controlled environments. These methods allow us to grow plants without soil, using nutrient-rich water solutions and controlled environments. This not only conserves water but also maximizes plant growth and yield. It's like giving plants their own personal spas, shielding them from the harsh Martian elements. By creating these controlled environments, we can ensure that plants thrive, providing a sustainable source of food for future Martian colonies. The ingenuity of Earth-based solutions is paving the way for a new era of space exploration and colonization. With each breakthrough, we move one step closer to making life on Mars not just a possibility, but a reality. Our journey to Mars is a testament to human creativity and resilience. As we continue to innovate, the dream of thriving on another planet becomes ever more attainable.
Hold on to your Martian hats, folks, because we're already growing food on Mars. Well, sort of. Right here on Earth, scientists are simulating Martian conditions in specialized labs. Picture this: greenhouses bathed in artificial light, mimicking the weak Martian sun. Inside, rows of plants thrive in Martian soil substitutes, watered with recycled moisture. It's like a sneak peek into the future of Martian agriculture. And the best part, we're not just talking about simple algae here. We're growing radishes, lettuce, even potatoes, all in conditions that mirror those on Mars. These experiments are proof that with a bit of ingenuity, we can coax life to flourish even in the most challenging environments.
So, we can grow food in labs. But what about on the actual surface of Mars? Enter biodomes. These futuristic greenhouses will act as protective bubbles, shielding crops from the harsh Martian elements. Imagine massive, transparent domes dotting the Martian landscape, each one a self-contained ecosystem. Inside, carefully controlled temperatures, humidity levels, and artificial sunlight will create ideal conditions for plant growth. But we're not stopping there. We're also exploring vertical farming techniques, maximizing space by growing crops in vertically stacked layers. Think of it like a Martian skyscraper, but instead of offices, it's bursting with fresh produce.
Section 6. A taste of home-preserving food for Martian voyages. Fresh food is fantastic, but what about those long Martian winters or unexpected dust storms? That's where food preservation comes in. We're talking about long-lasting, nutrient-rich options that can withstand the challenges of Martian storage. Freeze-drying is a leading contender. This process removes moisture from food, preserving its flavor and nutrients for extended periods. Imagine opening a pouch of freeze-dried strawberries on Mars, a taste of Earth millions of miles away. But it's not just about fruits and vegetables. We're also exploring long-term preservation methods for other food sources, ensuring a diverse and sustainable diet for future Martians.
Section 7. Beyond potatoes, the quest for diverse and nutritious Martian diets. Let's face it, a diet of just potatoes would get pretty boring even on Mars. That's why we're not stopping at basic crops. We're on a quest for a Martian menu that's as diverse as it is delicious. Algae, for example, is a powerhouse of nutrients and can be grown efficiently in controlled environments. Imagine Martian smoothies packed with protein and essential vitamins, all thanks to these tiny green wonders. And then there's lab-grown meat. Imagine enjoying a juicy burger on Mars. No livestock required. This technology is rapidly advancing and could provide a sustainable and ethical source of protein for future Martian colonists. Section 8. A united front. The power of collaboration in space agriculture. This journey to Martian agriculture isn't a one-man show. It's a global effort, a testament to the power of collaboration. Scientists, engineers, and space agencies from around the world are pooling their knowledge and resources to make this dream a reality. From universities developing cutting-edge hydroponics systems to private companies designing Martian greenhouses, it's a united front pushing the boundaries of what's possible. It's a reminder that when we work together, there's no challenge too great, no frontier too distant. Section 9. From Mars to Earth and beyond. The future of food is growing. As we look to the stars, we also look at the potential they hold for revolutionizing our food systems. The innovations driving Martian agriculture aren't just for future Martians, they're transforming how we grow food right here on Earth. These advancements are bridging the gap between science fiction and reality, bringing futuristic farming techniques into our everyday lives. The technologies we develop for space can help us tackle food security challenges, reduce our environmental impact, and create a more sustainable future for everyone. From hydroponics to aeroponics, these methods allow us to grow more food with fewer resources, making it possible to feed a growing global population. Imagine vertical farms sprouting up in urban centers, providing fresh, locally grown produce. These skyscraper farms could drastically reduce the carbon footprint associated with transporting food, while also making cities greener and more self-sufficient. Picture arid regions transformed into fertile lands thanks to water extraction techniques. Innovations like desalination and advanced irrigation systems can turn deserts into lush, productive landscapes, ensuring that even the most inhospitable environments can contribute to global food production. The possibilities are as vast as the Martian sky itself. With each technological breakthrough, we move closer to a future where food scarcity is a thing of the past, and every corner of our planet can thrive. So, the next time you bite into a salad, remember that its journey might have started with a dream of feeding a colony on Mars. The innovations that make space farming possible are already making their way into our kitchens, ensuring that we have access to fresh, nutritious food no matter where we live. Our pursuit of space exploration is not just about reaching for the stars, it's about ensuring a brighter future for life on Earth and beyond. The research conducted in space has far-reaching implications, from improving crop yields to developing new ways to grow food in challenging environments. The future of food is growing, and it's looking out of this world. As we continue to push the boundaries of what's possible, we pave the way for a more sustainable, resilient, and abundant food system for generations to come.
And settlement. Join us as we explore the exciting possibilities of sustainable farming on Mars. We'll delve into the innovative technologies being developed, the scientific breakthroughs, vision a future where humanity can thrive beyond Earth. Why is farming on Mars so crucial? The answer lies in our quest for sustainability and independence. The answer is simple: sustainability. Establishing farms on Mars is not just about growing food, it's about creating a self-sustaining ecosystem that can support human life for the long term. Relying on constant shipments of food from Earth is not feasible for a permanent Martian settlement. The logistical challenges are immense. The journey is long, expensive, and subject to unpredictable delays. Each shipment must travel millions of miles, taking months to arrive, and any delay could jeopardize the survival of the colony. Growing food on Mars is essential for self-sufficiency. By cultivating crops on the red planet, we can ensure a steady and reliable food supply. It allows us to create a closed-loop system, where resources are used and reused. Water, nutrients, and waste can be recycled to support plant growth, reducing the need for external inputs. This reduces dependence on Earth, making a Martian colony more sustainable and resilient. A self-sufficient colony can better withstand the challenges of space living. Imagine a future where Martian farmers tend to crops under glass domes, supplying fresh food for their communities. These greenhouses could become the heart of Martian society, providing not just food, but also a sense of normalcy and connection to Earth. It's a future where humanity has taken a giant leap towards becoming a true spacefaring civilization. By mastering the art of farming on Mars, we pave the way for further exploration and colonization of other planets, ensuring the survival and growth of our species beyond Earth. Mars presents a formidable challenge for any farmer. Its environment is harsh and unforgiving. The soil lacks essential nutrients. The atmosphere is thin, offering little protection from harmful radiation. Temperatures are extreme, swinging wildly between day and night. Water, the lifeblood of any farm, is scarce, locked away as ice beneath the surface. But these challenges are not insurmountable. By understanding the limitations of the Martian environment, we can develop innovative solutions to overcome them. Our journey to Martian agriculture begins by acknowledging the stark realities of this alien world. It's a world that demands ingenuity, adaptability, and a relentless pursuit of solutions.
Traditional farming methods won't cut it on Mars. The harsh, barren landscape and lack of fertile soil present unique challenges that Earth-based agriculture simply isn't equipped to handle. The Martian environment is unforgiving, with extreme temperatures, high radiation levels, and a thin atmosphere that makes growing crops a daunting task. We need innovative techniques designed for this alien environment. Advanced technology and creative solutions are essential to overcome these obstacles. Scientists and engineers are developing cutting-edge farming equipment and greenhouses specifically tailored for Mars, ensuring that we can cultivate life even in the most inhospitable conditions. That's where hydroponics and aeroponics come in. These soil-less farming methods are revolutionizing the way we think about agriculture, making it possible to grow crops in places previously deemed impossible. By eliminating the need for soil, we can bypass one of the biggest hurdles of Martian farming. Hydroponics involves growing plants without soil. Instead of relying on traditional soil-based methods, plants are grown in nutrient-rich water solutions, providing them with all the essential minerals and nutrients they need to thrive. Instead, roots are submerged in nutrient-rich water solutions. This allows for precise control over the nutrients the plants receive, ensuring optimal growth conditions. The water is carefully monitored and adjusted to provide the perfect balance of nutrients, promoting healthy and robust plant development. This method is highly efficient, using less water and space compared to traditional farming. Hydroponic systems recycle water, reducing waste and conserving this precious resource. This is particularly important on Mars, where water is scarce and must be used judiciously. Aeroponics takes it a step further. By suspending plants in the air and periodically misting their roots with a nutrient solution, aeroponics maximizes oxygen absorption and promotes even faster growth rates. Plants are suspended in the air, with roots periodically sprayed with a nutrient mist. This method ensures that the roots receive ample oxygen, which is crucial for their development. The nutrient mist provides all the necessary minerals, allowing the plants to grow quickly and efficiently. This maximizes oxygen absorption, leading to faster growth rates. The increased oxygen availability accelerates the plant's metabolic processes, resulting in quicker and more vigorous growth. This is particularly advantageous in a Martian environment where maximizing efficiency is key. These methods are ideal for Mars. They provide a controlled environment where temperature, humidity, and light can be carefully regulated, ensuring optimal growing conditions despite the harsh Martian climate. They allow for controlled environments, crucial in the face of Martian extremes. By creating a stable and predictable environment, we can mitigate the risks posed by the planet's extreme conditions, ensuring the survival and productivity of our crops. They also conserve precious resources, a key consideration for any off-world settlement. Efficient water use and recycling systems are integral to sustainable farming on Mars, making it possible to support human life and establish a self-sufficient colony on the Red Planet.
Section 5. Water, the Martian lifeblood. Water is scarce on Mars, but it's not absent. Subsurface ice and hydrated minerals offer a potential reservoir of this life-giving liquid. Extracting water from these sources will be crucial. Techniques like subsurface drilling and atmospheric water harvesting could provide a steady supply. Once extracted, water can be purified and recycled within the closed-loop system of a Martian farm. Every drop is precious, demanding careful management and efficient utilization. Water on Mars represents more than just a resource. It symbolizes the potential for life itself, a testament to the ingenuity of humans venturing into this new frontier. Section 6. Bringing the sun to Mars. Sunlight is another challenge on Mars. The red planet receives significantly less sunlight than Earth. To thrive, plants need a consistent and reliable light source. The solution? Artificial lighting. LED lights are ideal for this. They are energy efficient and can be customized to emit specific light wavelengths that promote plant growth. Imagine rows of plants bathed in the warm glow of LED lights, thriving within climate-controlled greenhouses. This vision of Martian agriculture highlights our ability to recreate and tailor Earth-like conditions in the most inhospitable environments. Section 7. The price of interplanetary delivery. Some might argue that shipping food from Earth is more practical than establishing Martian agriculture. However, the sheer cost and logistical challenges make this unsustainable. Imagine the expense of launching a spacecraft filled with tons of food, only for it to arrive months later. The risks are substantial. Delays, accidents, and unforeseen events could jeopardize the entire food supply. Local food production on Mars is not just about convenience, it's about survival. It's about ensuring food security for a burgeoning Martian population, free from the constraints of earthly logistics. Section 8. Lessons from Earth's extremes. Have we already faced similar challenges on Earth? Absolutely. Look at the farmers in arid regions or those who contend with harsh winters. They've developed innovative techniques like drought-resistant crops, vertical farming, and greenhouses to overcome environmental limitations. These earthbound solutions provide valuable insights for Martian agriculture. The challenges of farming on Mars might seem daunting, but they're not entirely unfamiliar. By learning from Earth's own extreme environments, we can adapt and innovate, paving the way for a thriving Martian agricultural system. Section 9. A Symphony of Science. Developing sustainable farming on Mars is a multidisciplinary endeavor. It requires the expertise of botanists, engineers, geologists, and countless other specialists. Imagine a team of scientists analyzing Martian soil, developing advanced hydroponic systems, and designing energy-efficient greenhouses. Their combined knowledge will be crucial in turning the dream of Martian agriculture into a tangible reality. This collaborative spirit, uniting diverse minds towards a common goal, embodies the very essence of human exploration and ingenuity.